Hey, section 8.2, looking at trigonometric ratios. So what you've seen before is sine, cosine, and tangent. We're really looking at an introduction to these three ratios using right triangles. So sometimes you'll hear me say right triangle trigonometry. Okay, I'm referring to sine, cosine, and tangent for these right triangles and using the sides of the right triangle. So the three we're looking at are sine, cosine, and tangent. Now when we do these inside the right triangles, we have to look at the angle we're doing and assign a name to the three sides in relation to the angle. So we're looking at, let's start with angle A, okay? Down here in the right triangle, looking at angle A and the sides in relation to that angle. So the side that is the longest, of course, is always the hypotenuse. And that's something you already know, okay? Now angle A, when you go to the other side of the triangle, so you go clear across the triangle, that side BC, is the opposite side. And then the leg that's next to angle A, or the side next to angle A that is not the hypotenuse, is the adjacent, or next to. Remember, linear pairs, we looked at adjacent only. Adjacent means next to. So the side next to angle A that is not already the hypotenuse. And when we go to fill out sine, sine is the ratio of the opposite side over the hypotenuse. So sine of angle A is the opposite over the hypotenuse. And so when you go to fill in the lengths of those sides, you have little a over little c. Because in a triangle, if you have, like for example, big A, the side opposite is little a. If you have angle B, the side opposite angle B is little b. And the side opposite angle C, little c. Now when you go to find cosine of an angle, cosine is the adjacent over the hypotenuse. So adjacent over hypotenuse. When you go to get the little letters for the lengths, adjacent would be B over C. Now tangent is the one that doesn't use the hypotenuse. You have the opposite over the adjacent. So tangent, opposite, and the denominator, adjacent. So when you're going to fill that in from the length of the triangle, that's A over B. And these ratios always hold up. So opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent. There it is. So to do sine, cosine, tangent of angle B, they're all the same ratios. But here's the thing. If you're looking at angle B, not angle A, the side labels are going to switch. Because for angle B, now side AC is the opposite. For angle B, side BC is now adjacent. Hypotenuse, of course, always the hypotenuse. So the ratios are the same, but the sides you're going to look at change depending on the angle you're looking at. The sides, opposite, adjacent, are in relation to the angle. So sine of angle B would be B over C. Cosine of angle B would be adjacent A over C. And for tangent, opposite over adjacent, B over A. So again, it all depends on the angle you're looking at, and the angle tells you what the sides are in relation to that angle. So we look quickly at example 1. Sine of J, we're going to look at the J angles, the J angle. So we have KL, the 60, that is opposite of angle J. 11, that is adjacent or next to angle J, next to but not the hypotenuse. 61, of course, longest side is the hypotenuse. So there's a little abbreviation acronym you can use. You've probably seen this before. SOHCAHTOA. What this means is that sine is the opposite over the hypotenuse. Can look at those three vertically, okay? Cosine. So cosine is the adjacent over the hypotenuse. Tangent, when I spelled out the other two, I'll spell out this one too. Tangent is the opposite over the adjacent. So angle J, opposite 60, hypotenuse 61. Cosine adjacent over hypotenuse, so 11 over 61. Tangent opposite over adjacent. The one tangent is the one that does not use hypotenuse. So 60 over 11. So you need to label the sides first, then you can fill out those ratios. So go ahead, finish example 1. Check if I completed the notes online, pause the video, do the work, check them, then resume the video. So now, remember back to chapter 5, we had those special right triangles, 45, 45, 90s. where the ratio lengths were the legs were S and S, the hypotenuse was S root 2. Then we had the 30, 60, 90 triangle. You have the shortest leg was S, the other leg S root 3, the hypotenuse 2S. So these ratios always hold up in every 45, 45, 90 and every 30, 60, 90 triangle. You always have these ratios. So we have special right triangles, we have special trigonometric ratios. Sine of 30 degrees, opposite over hypotenuse, S over 2S. And of course the S's cancel out. And 1/2. Sine of 30 degrees is always 1/2, no matter how big or small the triangle is. Sine of 45. Now 45, opposite over hypotenuse, so S over S root 2. Now of course the S's cancel out again. So you have 1 over root 2. But we can't have a square root in the denominator. We gotta rationalize the denominator. So remembering back to algebra 1, gotta multiply the top and the bottom by root 2. Kinda like mathematical grammar. You can't have a square root in the denominator. So multiply across now, so 1 times root 2, then root 2 times root 2 is root 4 or 2. So every 45, 45, 90 triangle has a sine ratio of root 2 over 2. For 60 degrees, opposite over hypotenuse, still doing sine, opposite over hypotenuse. So in the 36 90 triangle, they have opposite from 60 degrees, that's S root 3. Your hypotenuse is 2S. The S's cancel out. You're left with root 3 over 2. So no matter how big or small the triangle is, if it's a 30, 60, 90, the sine of 60 degrees always root 3 over 2. When you go to do cosine and tangent, again just doing the proper ratios, so Gotoa. So cosine adjacent over hypotenuse, tangent opposite over adjacent. Take a moment, pause the video, fill those in, check with my complete notes online, then resume. Now the last thing we're looking at, example 2, is solving is for a specified side in a right triangle. So it's important, kind of like writing proofs. Identify your givens. What do you know first off? So we know that we have the we know we have 15 degrees. We know we have 10.2. The 15 degrees, that's 10.2. That side in relation to that angle, that is opposite. So we know angle B. We know AC. AC is the opposite. And we're trying to find BC. See where it goes from here, bring it down, okay. And we're trying to find BC. BC in relation to angle B is the adjacent. So we're working with opposite and adjacent. So you gotta think to yourself, which trig ratio uses opposite and adjacent? Is that sine, cosine, or tangent? and that is tangent. So tangent of that 15 degrees is going to be opposite over adjacent. So 10.2, and let's call BC as our unknown. We'll call it x, okay? Now to solve for x, multiply it over. So you have x times the tangent of 15 degrees equals 10.2. Then, to get x by itself, divide by the tangent of 15 degrees. Tangent of 15 degrees, that is representative of some number. So treat it like a number. Like, assume it's 5. You have x times 5. So divide by 5. So now tangent 15 times x, divide by tangent of 15. So 10.2 divided by tangent of 15 degrees. And I'm not a genius, so I'm going over here. Just make sure you're in degree mode. Alright, 10.2 divided by tangent of 15. To get 38, I want to round to 3 decimal places, what to tell me. So 38.067 is the unit feet. Alright, so using what I know, writing out an appropriate trig ratio to solve for the unknown side. So take a look at the other two, check your answers with my complete notes online.